Alright.
You know, you could make that a lot easier to work with.
Here we go. This is called Zebedee.
Cool.
Energy.
It is a laser scanner, so when it's working there's a laser beam coming out, but it's eye safe, so don't worry about it. So usually this is a surveying tool, but in the talk I'm going to speak not just about Zebedee, but about how scanners can be used in games, potentially. Anyway, this is Zebedee, which is an invention, well, it's basically an invention by Rob. This is Rob here. So we're lucky enough to have the inventor, or possibly co-inventor, of the product. And it was developed at the CSIRO here in Brisbane. And what is it? Well, has anyone heard of LiDAR? Yeah. So that's the same as a laser rangefinder, and the principle is that, well, this is the non-technical principle, but you fire a laser out, and whatever it hits, you get the range to that point. So you're not going to build a very good environment just by a single laser and getting a single range point. The next step is that most companies that sell LiDAR make spinning LiDAR. So what we've got here is a small laser, an infrared laser, so you can't see it, and there's a spinning mirror in here, so the laser sweeps out a movement like this, 270 degrees, and so that gives you a distance to all of the points in a plane. And some of you might have guessed now why it's doing this. Right? You only get a two-dimensional map if you only get points in a plane. So by nodding it, the sweep, which is very fast, this is 40 times a second, but you nod slowly. So this sweep gets, you can think of the plane moving up and down as you do this. And the idea is that you walk around roughly at a walking pace like this, and it maps the environment. So again, some of you might have thought that's not really enough to get a three-dimensional map. If you know exactly where this is at every point in time, and you know what orientation it is, then you can work backwards from your range data, and you can build up a map. But how do you know where it is? And so that's the tricky part. Basically it uses a field called SLAM, which is simultaneous location and mapping, and instead of trying to use GPS satellites or compasses to work out where you are, you actually use the data that you're receiving about the environment. You make some assumptions, you assume that it's not moving, which is why I told a few of you guys to freeze when I took a map just at the start. And we assume that the environment's not moving, we assume that the geometry has got some sort of surfaces to it, and based on that we do lots of complicated maths and come up with three-dimensional models. So we've also got a little IMU, inertial measurement unit, in this, which helps us. An IMU tells you the acceleration and the angular velocity of the head of the Zebedee, and so that helps us to find out where we are, but it drifts, so you can't rely on it 100%. Anyway, so that's the hardware. And I did a little run around at the start. I think most of you saw that. So I'll show you that at the end, what the results look like. But first I'm going to talk a bit about how you can use things like this in games. By the way, this backpack, principally it's just where you store the battery for this, but we also are logging to a laptop at the moment. you want to say
show
anything?
the battery and
Yeah.
the size of it and things like
Yeah,
that.
sure.
The real computations are offline, is it? The real computations are done offline, not...
At the moment they're offline, but they are computable in real time, so they don't have to be. It depends what you want to do with your hardware. See, this is a laptop, which it's real. Its only use really is to log the data straight to a memory card, and later we process it, which is what Rob was doing whilst he was giving his talk. If you thought he was ignoring the talk, he was busy computing it.
What sort of spec is the laptop?
I don't know.
Well, that one there, I mean, that's just an acquisition laptop. That one can be, that's just like a cheap netbook. The processing laptop I was using was MacBook Pro that's about a year and a half old. Doesn't have to be too fancy to compute. That's, we could run it on that, but it would take, definitely not go in real time on that. But, any sort of decent laptop in the past 3-4 years is good enough.
This battery pack would last for about
That's about
4
6,
hours.
power in the sensor, that'll last about 6.5 hours. We have some where we can power the laptop off of that as well, and that cuts the time in about half. But the laptop battery will last 5 hours or so anyway on its own, so we typically don't do that.
I'm sort of surprised you don't just plug it into a sending unit and plug your sending unit into your good computer.
I mean, streaming the data.
Send it, yeah.
We can.
Straight across
Yeah,
the
I mean,
files.
most applications we look at, we don't need real-time processing anyway.
And you're gathering from your videos in like outdoor environments and bathroom.
Yeah, I mean, we were taking it into outdoor environments, into caves, into underground
Yeah.
mines, into forests. So
That's
we don't normally have like an office environment where we have a
It's
table set up with a
smaller.
laptop and Wi-Fi and all that stuff.
Alright, we can talk a little bit more about the hardware at the end, and I'll show you the results. We're going to talk about laser mapping for 3D worlds for games. It should be sort of quite a short talk. We can go next. Right. Right. Okay. So the start of this is that building content for games is expensive in terms of man hours. We take Rockstar North, that made Grand Theft Auto 4 and 5, 3 years, all of them really. Currently they've got about 150 artists and level designers, and their games, hard to say exactly, but roughly 3 years to make a game, let's say, something like that. So that's getting on for about 1 million man hours to make a game, and a lot of games these days, I'll probably say more and more, are looking to be more realistic in a lot of ways. And as Mark Rubin said, games are becoming harder to make and they're becoming more expensive to make. And that's referring to AAA games, really. So an answer is, well, digitize the real world. Right? A lot of people are against that, but when you think about it, we already digitize voices, we already digitize sounds, we already digitize animations for characters using mocap. So
Might be cheaper to hire a set builder, build your fantasy layer,
Yeah.
and cardboard.
Yeah.
Cardboard or plywood, whatever.
if you want to do fantasy, if you want to do realistic, you have some privacy concerns, but you can, you can digitize a forest or whatever you need. Much easier to find one than to make one.
I've
So-
got a curious question. Like, compare this one compared to, let's say, like David laser scanner software.
Compared to what?
The David laser scanner software.
Yeah. So that's an object scanner.
Yeah, I know. That's
Okay, I'll show you next slide. This is the next slide.
Oh,
So this is like an environment scanner.
yeah,
whereas everything's
I
an
understand.
object.
I was just saying, could it be used as an object scanner as well?
Not for the
Because
same
you were
scale of
saying
objects.
slightly
So
res.
the range precision, so sort of the noise you get on your range measurements, is about a couple, somewhere between 2 centimeters, somewhere in that range. So if you're trying to say digitize that bottle there, that kind of noise is not going to result in a good object. So objects at that scale, you would want a different sensor for.
But if you go to scan a jumbo jet or something, that would work really well.
Yeah, and we've done that. So, yeah, we'll swap for that.
Okay, so that is what I'm talking about presently in this slide, which is that there's various different ways to map the real world. These are not all of them, these are just some example pictures. On the top left, we've got a Faro scanner, and this is a tripod scanner. Costs about $50,000.
In that range.
In that range. And the piece at the top there on the tripod, it spins around slowly over a period of about a minute, and it scans the environment very carefully and gives you a high resolution colour, three-dimensional point cloud from, and this is important, from only the perspective of where it was, obviously.
Could you use that in mining or something like that?
Yeah, you can use it in all sorts of applications. So advantages, high resolution, colour, disadvantage, expensive, and if you only map one location at a time, you get what we call shadows, which are occlusions. If I map from here, where my head is, you're not going to see any of the stuff around here, right? So
you have to move it and reset.
yeah, it's got some disadvantages. The top middle one is some open source. This is kind of more like university research papers into the idea of RGBD SLAM, which is there are some sensors which give you red, green, blue, and depth, and like the Connect and the Connect 2 sensors, particularly the Connect 2. And there's some work going on where you take the Connect and you just move it around very slowly, and it'll give you colour and position, and again it uses SLAM, simultaneous locational mapping, to match it all together. The disadvantage is that it's not really a commercial product at this stage, and it's slow, and it's to be seen what will happen with that. Another example of scanning the real world is you can scan objects, as you were saying. A couple of bits of hardware are the Mantis Vision and GoScan 3D. GoScan 3D is made by the same company that actually commercializes the Zebedee, actually. So, like I say, that gives high detail, but you do it for a particular object. You want to scan a stone or a big elephant. God. A couple of other options. Quite popular these days is photogrammetry techniques. This is the bottom left and bottom middle, are two examples of this. So basically, take two photos and do some clever maths comparing two photos, and that gives you a three-dimensional image of a surface. Advantage is colour, high detail. Disadvantage, you're kind of limited to the geometry. Undulating surface is fine. Trees and bushes and things, including other things.
You also don't get scale from it. You can do, it doesn't have to just be two images, you can have n images, but you don't know your scale.
Yeah. And this is the same thing. SenseFly is photogrammetry. This is a three-dimensional model that you're looking up there of the Matterhorn, and this is accurate. This is done using little drones. They've chucked into the air about 15 drones, little radio-controlled automatic planes, I think it was, and they fly all around the actual mountain taking photos, 2,000 photos, and lots of clever maths later, and they work out the structure of it.
Microsoft used to have an online site where you'd submit photos of things, and somehow we'd work out where the photos were taken from and collate them all together.
Yes, yeah, I don't know what that's called, but what's that?
Photoseed?
Yes, that's it.
That was using structured motion, which is sort of similar vein as this photogrammetry.
And finally, mustn't forget, bottom right, we've got Zebedee here as an example. Currently, its use for for games is kind of limited because it's not colour. It's more of use for surveying and things like that. So the downside is it's not colour. We can strap a camera to this and do some even more complicated maths, and we can colorise it fairly well, but it's not commercialised yet. The advantage of this, specifically over this one here, well, over all of them really, is that it's handheld and you don't need to stop and scan. So everywhere you go, you're scanning. And this is an example of called Oracle?
That's like Questacon.
Of a very large building, possibly 3 stories here, hundreds of meters in length. You can just walk down all the corridors and poke your head around all the doors into the cupboards and scan as much as you want.
Let's go to the camera.
Yeah, that's one camera. And
Does
there's
that only scan from the inside?
Yes.
those parts you can see there on the outside,
Yeah.
sort of in the foreground. And that whole scan was done in like 14 minutes or something like that.
Yeah. So yeah, this is a lot of the Zebedee scans you scan from the inside. So if you're interested in seeing what it really looks like, which I'll show you at the end actually, it's from inside.
But that's the interesting part.
Yeah.
For a game.
So this has got a range of between 10 and 30 meters practically. So the outside of large buildings, it's difficult to actually stick your hand out of upper windows, which we do sometimes.
Or dangle it from a helicopter or have it all around.
So the Faro is 50 grand, right? How much is the Zebedee? 23?
In its commercial.
In the commercial,
Yeah. You can buy it at all good websites,
With the software
as
as
long
well.
as they're 3dlasermapping.com.
The software as well.
It comes with, it's a cloud-based system, so upload your data and get results. Okay, so it's a nice idea to scan real world for games, but it's got 3 problems that I can identify. First is the meshing problem. All of the scanners that I've shown you so far generate point clouds, and games don't work with point clouds. So we've got a problem of how to convert a mesh to a point cloud, the other way around. And I think it's correct to say it's a bit of an ill-posed problem because there's not a one-to-one mapping between point clouds and a correct mesh. There's a lot of interpretation that's required. And certain things don't mesh well at all. Bushes, trees, big bales of hay, nets, cables, birds' nests, weird fir trees, strange things like that. They're not really surfaces, so they don't mesh well, which is a problem. Anyway, there's several algorithms out there that you can use to mesh as best as you can. A very popular one is Poisson reconstruction, and that's in the picture, and that's a point cloud, and that's the mesh that it's produced. There's other ones, Delaunay triangulation is quite simple, ball cavity, etc. And there's different bits of software you can use to mesh your point cloud. 3D Reshaper, I think $6,000. MeshLab's free, Point Fuse, I don't know how much it is. £100 you can do a single point cloud with Point Fuse. Or the alternative, I don't know if we've got anyone from Euclidean here, but Greg used to work at Euclidean. We've got a Brisbane company here, Euclidean, that actually has a very fast point cloud renderer. So an alternative is, well, maybe you should make your game out of point clouds. There's a fast renderer, but it's got some disadvantages as well. It's hard to make things move, and you've got to be very careful of gaps when you make things out of points. Second problem is the lighting problem. Most games you want to have lighting in it. If you want the lighting on your characters and all your props to match the lighting in the level, then you want to use the same lighting model. But when you scan the real world with colour, it's already got lighting. So there's not so much commercial software to solve this problem, but there's definitely papers and research out there. The example I've given from a SIGGRAPH 2004 paper takes, well, it's actually a 3D scan of the Parthenon here on the left, and it does some clever maths to unlight it. So it's taken all of the dark parts out of it, and at the same time work out the position of the sun. And then this is the render, where you put the lighting model back in again. That's fine if you've just got a single sun, but you can imagine it gets complicated quite quickly when you've got different
If you did
times of...
at night when it's all illuminated by 100 floodlights and stuff like that.
Well, expand your lighting complexity to more lights, specular lighting, different forms of gloss maps available, refraction, it's a tricky problem in general. And the third problem, I've got a very good name for it, but when you're making a game, you don't want just a concrete world, right? You want things to react, otherwise it's not a very fun game. Trees should sway in the breeze, doors should open and close. If you hit a lamppost with a car, it should bend. All these things you try and put into a real game. So how would that work with digitizing the real world? Well, again, we're getting further away from commercial software, but there's a lot of research on object recognition. So in these pictures here, there are 3 colorized point clouds, and one of the papers here is looking at finding particular objects within the point clouds. So once you've identified the object, you can find its dimensions and you can extract it, and that's your first step to actually adding behavior, right? But each of these problems is sort of progressively harder and progressively more researchy.
That is when you build them, you've got to fill that hole.
Yeah.
Yeah, so if you can identify the desk as an object, then that helps. Yeah. So, difficult, but I expect there'll be some games, more and more in the future, that use direct digitization of the real world. Okay.
Regarding objects, wouldn't a solution be to simply use mapping for the environmental stuff, and then use more commercial techniques for objects?
It's not hybrid.
Yeah, sort of props and real world. I mean, you can use an object scanner to scan the individual object.
So props
Yeah. Yeah, back in sort of the 90s, you'd have games which were a bitmap graphic for the environment, and anything that moved was actually made out of textured polygons, like Alone in the Dark and stuff like that. And you could always tell which things you had to go and interact with, because you could see that they were... Yeah.
The feature.
So you've got to be careful that they match with each other.
like a cartoon over a photograph.
Yeah.
Yeah, 2D point and click adventures. The background to be some big cartoon thing.
Yeah.
Well, foreground's not very big cartoon.
You know, you're going to be interacting with that polygonal object
Very,
at
very
some point.
graphical
Yeah.
style.
Disney has that problem.
Yes.
Do they want
They do.
Yeah.
It's cell shaded.
characters on a painted backdrop.
Alrighty, I'm going to load up the model that I scanned of this room and out the door.
Is it possible to see a visualization of the point cloud being mapped to the outside?
There's a video.
I've got one online. Maybe, the internet speed isn't great here, is it, for video?
So the big question for you is, what's the size of the data while you're collecting it? What's the size of your data after you've processed it?
When you're collecting it, it's about probably up to around 100 megabytes, sort of.
Well, it's about 10. It's under 10 megabits per second per minute. So it's not very much. We get about 100 megabytes for 8 minutes or so. So sorry, maybe a little more than 10. It's like 13 or 14 per minute. And then the output data just depends. I mean, you can see here the files here have different percentages of the data in them.
Yeah.
So sort of
This
depends
one's
what you
just
need.
9% points because it gets a bit slow. But when you
But it's a small map, so you might as well bring up the bigger versions if you want.
actually use it with a mouse. Okay. Yeah. Okay.
So see the shape on it.
Shape one, yeah. But it's indoors, so I don't know how that works.
It's not the shade, it's not the ambient occlusion, it's just the, it has lighting, like surface normal, so you can,
Okay, then Control D.
And then do render colors none. Okay. So right now it's colored by sort of shape, sort of surface normal and shape locally. So things that are flat are colored differently than things that are a bit more lottery.
Okay, so I'll
Go
do
up to
the-
render, color none, and then you can shrink the point size as
Yeah,
well.
yeah.
So quickly.
So I'm going to be viewing this from where I'm sitting right now, which is in here. Here we are.
You tell me stood still.
Yeah, someone was moving. I think it's that mess there.
You've got no.
That's great.
Right at the edge of the building.
So it's not the best application for doing a walkthrough because when you zoom forwards, it moves the lit
Oh,
file
you can move
inwards.
you can move the clipping planes with control and scroll wheel.
Shift or something.
Control shift and scroll wheel to
There it
get
is,
that
got it.
one.
But it'll still come in when you zoom forwards, doesn't it?
Or you can just play some marker. Like,
Is this a program that you guys have developed, or is this?
No,
No,
Mesh
this
Lab
is
is
open
freeware.
source.
Yeah. Yeah, it's just got not a great control system for first person moving around. Anyway, you get the point. This gives you an idea of the number of points we collected. And here you can see an sort of occlusion, what we call a shadow. Which I guess it was, is that I don't know.
Not bad for free software, is it?
Yeah, pretty
Big
fast.
point clouds.
And these are rooms for C, for B, and for A.
or you can open the trajectory as well, so you can see like the rooms on the side there. You can even go into. This is just seeing through the glass.
Yeah, so there's a lot of glass here, and you'll see the laser basically goes through the glass, but sometimes it will catch the glass.
So if you open, if you go to the third button on the top, or well, just the icon, that one there,
Okay.
So
and then go to the one, trajectory.
notice the kind of mirror.
It looks like there's another room. It looks like you think if you didn't know what a mirror was. Yeah, that's what it looks like.
I suppose for surveying purposes, this is plenty because you have lots of points to do measurements of. But what other uses do you envisage for this?
Well,
I mean, obviously, again, you're talking about
you
this.
Put lighting back
You
on.
can make entire simulations for companies, for instance, where you walk through their warehouse, for instance.
Check files in there as well.
Okay,
What's that?
your new process will
You
do
can see where you
this.
wobble the controller.
Yeah, exactly. So the trajectory is literally the trajectory of the head.
Just games, like.
I think there's some training and
games,
simulation would be.
Well, more for, let's say,
Very similar,
architectural
sort of like the,
redesign and shit like that.
Yeah.
Camera tracking.
Right.
You change
Processes.
2D shot.
any place where you can the camera starts and actually find the points in the shot, track them through trying to interpolate a track
just
like from the camera itself.
introduced
And then
like a
second, you
whole
place like 3D elements
new
into the scene.
layout and a
Familiar
new
with that
layout
technique?
on a massive scale.
No, I don't quite get what you meant.
Okay, so
For what purpose?
That's just object
They
location.
can simulate.
Sorry?
That's just
some
object
GPS
identification.
allocation.
well, there's some quite smart ones now that actually
And spot
do
problems
it like a full
before they
3D camera move, so not just a pan and dolly, like a full rotation and everything. So you just like you
business side.
get there's the 2D information from a regular camera shot,
Yes.
and you pick your points on it based on best off with like high contrast or something like that.
Good edges
And
and
then,
stuff.
yeah, and the software will go out and try and pick a cloud, or like as many of them as possible, and then just track them in 2D and just try and interpolate a camera track from that movement, from the information it gets.
That's
Okay.
it used to be moderately high end. That
Yeah,
That
well,
sort of thing.
throughout my time in visual effects, it got more and more mainstream and that sort of stuff. First of all, then if you pick like a dolly or like a side track or something like that.
but now you can pick up all the levels.
Yeah, yeah.
That would work very well.
You can also find some software for the Voodoo camera tracker, and that's a paper, and that's from Germany or something, and that does similar, not quite, nowhere near as good as this stuff.
Surely Autodesk or someone would have that sort of tracking software.
But I was going to use a plugin for Shape to do it, but yeah, I think there's like a few standalone versions of it now. But it would be surprised if what's their solution called After Effects or something? It's got some sort of solution built into it now.
Okay, well that's the end of my demo. If anyone's got any other questions, free to ask. Someone asked what other applications could it be used for. One advantage of this is it doesn't require GPS, so we've already mapped some caves, which has been very useful for heritage reasons. We are collaborating with a games company, so we can do it.
Yeah.
So this is commercially available now?
Yeah, it's great tech. It's out of my price bracket. It's really good tech.
Yeah, well, next year's model, take a zero off.
Well, a lot of people get interested. I suppose they can redesign it and find cheaper ways to do the same thing.
At the cost of resolution and stuff like that, but.
No, not necessarily. I severely doubt that.
Well, the issue at the moment is the laser scanner we're using. There aren't very many products of that size.
Oh, yeah.
And this is the only one of that size that has range beyond 4 meters.
Yeah. And
So-
again, like that will come like as popularity grows
Oh,
for
yeah,
that
yeah.
product.
And that'll
They
happen.
will develop better lasers and whatnot for that.
Yeah, and this will work. And this will work just the same as we, if we put another laser on. If the laser gets better, more accurate, smaller, farther range, same technology will work. But right now on the market, this is the only one that exists, and that's really the biggest component in terms of price.
Yeah, like next year might be in your phone.
What were the biggest challenges with the software part? Once you've got the data from the sensor, what's the hard bits?
Pretty much everything from there, I think. I mean, we really need to know all the time very reliably where you are, and we know that, where we've done sort of lab tests and things like that, we've put on Vicon tags or compared against other systems. We're within less than a centimeter on our positioning. If we're over longer distances, like if we're say scanning a cultural heritage site outdoors, it sort of drifts over time. So you drift off a bit farther, but then if you close your traverse off, it will reduce. But basically, just getting it so that it's really reliable everywhere. Because if you have one glitch in your data set, it's going to mess up the whole
What's
thing.
the range of that again?
So it depends on ambient lighting and your surface type. So the manufacturer reports 30 meters. We get something like 30 meters, even more than that if we're underground in caves or mines. But if we're outdoors and it's sunny out, we get something more like 15, 16 meters.
So you'd be better off scanning at night, so.
That could improve it, yeah. That's not always
Yeah.
possible, but yeah, we should get a bit more range in that case.
Because the infrared-based guns and things people play games with, they work better at night.
Yeah, oh no, it would, but it still does work. I mean, 15 meters, or what, 15 to 20 meters is pretty good for
So,
a lot of applications.
Just curious, how many units of Google bought for their cars?
Yeah, they're actually using another one that Tom didn't have. The one they have on their car is one that has 64 lasers, and then it spins at 20 hertz. And so they're getting over 1 million points per second. But those ones cost about, well, I don't know how much they're getting them for, but on the consumer market they're about 80,000 US, and they're quite big and heavy.
Not really handheld.
Definitely not a handheld thing.
So where do they mount them in the cars?
They put them on the roof.
Yeah, they're pretty small actually.
The one they have, well, it's like the size of your head basically, and they get sort of a toroidal kind of field of view, so they're not going to see things very up close next to the car, so you can't really detect obstacles that are very close. You can't see the curbs and things like that, but it's very good for detecting things further away because it has such a high refresh rate. You can track vehicles and sort of see things that you need to very quickly. With that, we're getting about 40,000 points a second, so it's an order of magnitude less points. And because that sort of sweeping motion is, every second or so, that the effective scene update rate is a lot slower. So if you wanted to put something on a vehicle, you need, and for that purpose, for sort of safety, you'd want something with a higher update rate.
Yeah, you're wobbling that with your hand, right, on a spring.
Yeah.
Why not have it mechanically moving and use the more precision from maybe the...
Yeah, we can do that. We have plenty of systems that work like that. The advantage to this is, so I'm actually, if I'm walking around with it, I'm not really wobbling it too much with my hand. It's the natural, accelerations from walking from your gait. If I stop to scan something in a bit more detail, then I'll move my wrist a tiny bit. The technology actually started, we had a spinning version where it was on a motor, and we had that mounted on a vehicle, because we're actually a robotics lab, and that we're looking at first at this for a sort of a 3D perception kind of system for earth-moving vehicles and ground vehicles. And we had that on a spinning motor, and it's actually exactly the same software we use. And our thoughts at that time were, okay, we had some interest in mapping caves and things like that, so how can we take this, make it more lightweight and simpler to be something you can carry around in tough environments. And brainstorming through that, we came up with this idea of the spring, and the advantage of the spring is it's mechanically simple and lightweight, so if you had a motor on there, you'd have to have more complex mechanism, it would be heavier, it would use more power, you'd have to have a slip ring or some other things that tend to fail a bit more often than the spring would. So it basically reduces the weight by probably, I don't know,
And that
a
chip
few hundred.
you got would be gathering data of where the spring moves anyway.
Yeah. So I mean, the difference is when we're having it on a motor, we can often just do away with the inertial sensor that we have on there because we can use the encoder on the, say if it's spinning or nodding up and down. We use that instead.
You'll be walking with it, and we'll be walking anyway. So I guess.
Yeah, except we know locally, if we're say on a spinning motor, we know how, and we do have some that we walk around with that are on a spinning motor.
And you would still have to figure out if you're.
Oh, no matter what, we'd have to anyway. Even the ones on vehicles that are on
kind
spinning
of for
motors.
free in that sense.
Yeah, so you get the motion for free. If it's a handheld thing and you need to scan for many hours, if you don't have to power a motor and you don't have to worry about the cabling and the sort of IP ratings and things like that, it's a lot nicer to have a spring, we think. But certainly we do have systems where they're on nodding or spinning platform motors instead, and we use exactly the same software and everything like that. It's sort of the same solution.
I was curious about the color acquisition. Have you got any examples of that?
Color
So you just strap the camera.
I have something here on a hard drive. I don't know if you have any.
Well, I'm right on the. I don't know if it's a good idea to log into the wiki from here. No, I shouldn't do that. But these are not colours. It's Questcon.
If you want to.
How much effort has gone into the software development for this?
Quite a lot. I mean, we've been developing it for a number of years. When we were doing the stuff on the vehicles, that was back in 2008. So it's been a few years developing. I mean, not all that time has been purely developing the solution specifically, but we've taken it from situations where we're mapping, something like the scale of this, like a few rooms, up to where we're mapping, tens of kilometers of caves or, entire cultural heritage sites that are, hundreds of meters by hundreds of meters and very complex. So a lot of it's gone into just improving the reliability, and then every time we go to these sort of very new types of environments, it sometimes poses a new type of challenge that we hadn't seen before, because there's something specific about the geometry that's a bit different from something else. And we've done enough of them that doesn't really come up very much anymore.
How many developers are working on it?
Mainly sort of the R&D developing it, there were 2 of us initially, and then Tom joined us a year and a half ago. So most of the software has been basically the 3 of us. So I'm just trying to. Oh no, wrong drive. Okay. No, I don't have color ones on this one.
Isn't 4-bit available on Wiki?
Logging in. I do have another drive possibly that would have more. So I just filled up my last hard drive, and this is one I just.
But basically, color-wise point cloud's difficult because the camera's not on the head, it's on the bottom. So we're sort of getting within about 5 centimeters or so accuracy. So you're not going to see writing on a wall, you're going to see the general color of things. But also, you wouldn't use Zebedee directly for digitizing terrain for a game anyway, because its resolution is, you could have 10 centimeters between points. It varies. So it's not really a dense point set, Zebedee itself. But it's just one tool amongst many that are available for digitizing the world.
From both your knowledge of sensors and lasers, do you have any suggestions on how you can accurately measure a distance at the range of, say, 1 to 10 kilometers? Meters? Sorry.
They do have scanners that do that. So mostly those tripod-based ones, they're called terrestrial scanners. And there's some that are used in the mining industry and a few other areas where they can measure, kilometer type distances. It takes a lot more power, it takes a lot more precise laser for the applications they're using, but it can be done. And these are, very huge, heavy laser scanners do that. There's also aerial scanners that do flyovers of sites, and they have, hundreds of meters type thing, but they sample very sparsely.
Now they've measured the distance to the moon using a laser, haven't they? So you can
All the
Tom,
signs.
there's a trick. There was people went there first and placed it as a reflector on it.
There you
Yeah.
go, emissions and
yeah.
So if you can land the reflector wherever first.
There's the thing, something that's lightweight and very long range and works through different weather conditions. That's what I'd like.
And cheap. And cheap.
Yeah.
Well, not
Yeah.
Under $100.
No, I'd like it cheap.
He's got some
He's picky.
How do I find where this is mounted? I probably haven't used Windows in many years.
Oh, do you want to just do
I
Windows
mounted a
8?
new USB.
Okay, it's in
Okay. I want to see what data has there. Time I have on colors.
locate.
Where something is
Oh yeah, you can change the view.
That's something.
That's just the view. It changes per folder from what viewer it uses. The sort of pension at the front, isn't it?
Yeah.
Trying to remember the
So you can personalise it and have everything different.
Every single folder can be a different view. It's really, really great.
It's cool.
If you right click, you can change the view to
For the
details.
source that's with it, rather than necessarily the program. Like the program is cool. Autodesk is actually
Details.
a product.
Or this, yeah.
They've created a product called PhotoFly, and it's basically carbon copy. And I was just like, are you guys serious? You've got me this open source so blatantly, and yet no, then they repackaged it and titled it something else. And it's just an absolute blatant direct copy of that same software. And they've said, oh no, it's in the cloud storage, right? And the only reason it's on the cloud storage is because they don't want to put the code.
The answer to the question is no, we don't have any comments.
And they want to be able to prove that it's the same.
We've all seen it.
Because once you can do that,
Yes, you just look at
others just violate
going to sites now.
source agreement. Thank you very much. Or that developer will take
But what's fun?
These guys are making their own software.
Because the caliber, that's really a hard problem.
I mean, it's really dangerous, so we've got guys in the same office that work with mine's got black the Oculus Rift, plus other bits of hardware. So we do recognise Oculus Rift is available.
If I showed you the 0.5, you would not be able to.
20 times like
I've looked at it, I haven't tried it.
It's like one of the in virtual reality,
It's a lot of money.
It's
a lot of money.
scan initially anyway. Everything we want to be is like as close to real life as possible, and then
Even the
it's like
connected is only like
Right.
Yeah, there's another thing.
like the
When you were scanning these kilometers of
that
caves,
software.
you actually have someone walking, like slow walking pace with it, kilometers.
Yes.
Did you put it on like a cart?
No, walking, it's sort of just dome. It's basically a normal walking pace, but we've done the whole of genome caves, and if you don't know genome caves, they're a huge cave system. They're like one of the biggest cave systems in the world. Absolutely huge. And it's not just walking, it's involved, not me that did it, but it's involved abseiling with, so you've got it in your hand, abseiling down the cliff. It's involved squeezing through small holes that are about the size of yourself with the zebedee, so it's all very important.
Can you have
The next,
can you have like multiple going at once and synchronize the results?
you can, yes you can.
Very much.
You can't have more than about 3, because what happens is the lasers interfere. Well, no, you can. Potentially the lasers can interfere with each other.
And that's something we're doing with this.
But because it's a spinning laser, so it's not a problem. The ones which are cameras, some of the ones which produce laser light and others entire rasterized views, they have problems with interference, but no, it's fine. So we've actually done that.
Alright guys, we might pack it up and head for a coffee if anyone's interested, or some lunch. So just give a round of applause for these guys.